masses, mass. Okay. And now we will going to discuss about the charges and all that. Okay. So I am starting the first chapter. So basically it is a part of electromagnetism. And this can be divided into two parts. This is just the introduction. In the electrostatic, we study charges at rest, and in electrodynamics, we study charges in motion. That's fine. So our unit is electrostatics. This is first unit. Is we will study this. And in this unit, we have chapter 1. Electric charges and fields. This is the introduction. This is the introduction, and this is a brief idea about what we are going to study.
Okay, sir.
Okay. Now, the very first thing is charge. In 11th class, we are familiar with mass, and now we are in 12th. Now we will deal with charges. So, it is the intrinsic property of matter which give rise to phenomenon like electric force, field, like field means electric field, and energy. And you will see these all the things in this chapter. You will see all these things in this chapter. So charge is the property of matter. Charge is basically the property of matter. And we know what is matter. Like you can say matter, anything which occupies space and have mass is known as matter. So you have heard about electron. Do you know about electron? What is electron? Okay. So like we know that electron and proton have charges. Electron have the charge, and proton also have the charge. So electron and proton, what is electron and proton? It is the matter. So it is, so charge, it have a charge means it have a property. So basically this is all about charge. And charge or of are of two types: positive charge and another is negative charge. There is no another type of charge in this world. And unit of charge, I am talking about the SI unit that we will use in this chapter. Okay, that we will use in this chapter is coulomb. COULOMB, and coulomb is represented by C, and charge is a scalar quantity. Scalar quantity means we can add the charges, like there is 2 coulomb of charges, 2 coulomb of charge, and we can add like 2 coulomb of charge, this will become 4 coulomb. So we do not need directions for charge, we can simply add the charge. Like suppose there is minus 2 coulomb charge and minus 6 coulomb charge, it will become minus 8 coulomb of charge. And now from here a very interesting thing will happen. Suppose I am giving you a positive charge, and this here is a, this charge is separated by some distance with a positive charge. So Ajmi, can you tell me, will they repel with a force or will they attract with a force?
They will repel.
Very good. This thing we know, repel with some force. Repel means, repel means I am telling, repel means this, suppose this is the line joining two charge, and means this charge will try to move this charge like this, and this charge will try to move this charge like this. Okay, that's fine, no problem. Suppose if there is a positive charge and there is a negative charge, and again this charge is separated by some distance, now this time they will attract with some force, no problem. Attract means this charge, due to this charge, this charge will try to attract this and this charge will try to attract this. Attracting means coming together, repel means going further.
Okay, sir.
Okay. And same is the case with negative charge. Like if I am, like this is negative charge, and they will repel with some force. But now here is a problem. Here is a problem. This force, some force, some force, and some force. We know that they have some force. They will repel with some force. They will attract with some force. But we don't know how much force, with how much force they will repel or they will attract each other. So this is the problem, and this problem is solved by one of the scientists named Coulomb, and he calculated this force with some experiments. So that is why in 12th we study Coulomb's law. If somehow we know this force, there is no requirement of Coulomb. Are you getting my points?
Yes, sir.
Okay. And if you have any doubt, then you can ask me. Now, that's why we are studying Coulomb's law. It is nothing but it tells the value of force. With how much force the charge will repel each other, with how much force the charges will attract each other. But interaction means attraction or repulsion. This law tells the interaction of charges. You can say force between charges. But this law says that if there are 2 point charges, if there are 2 point charges, what is the this law says that Coulomb says that point charges. Point charges means very small charges, very small charges, like a point you can say. But uh, what is the real meaning of point charges? And remember one thing, this Coulomb's law is valid only for when there will be when we want to find the force between 2 point charges. Only point point is very important, point charges. So what is point charge? Let's discuss. And after that I will come to the this law, point charge. There is no fixed definition of point charge. No fixed definition of point charge. But we can say charge in very small spaces space small space as compared to the distances. So let's see what does it means. Suppose this is point charge or not, this very small charge. Can you tell me this is point charge now? Is it fine?
Yes.
Okay. Now we knew that this is point charge. Very good. Suppose if I am taking a charge here and whose radius is 1 1 meter. Can I say this charge as a point charge?
Yes, sir.
How? Okay, no problem. I am telling you, I can say this charge as a point charge or not a point charge. It will depend upon the distance. Suppose if someone is in US and he or she is looking at this charge,
Okay,
So
sir.
so this charge will become like a point, na?
Yes, sir.
So in this case, I can say not America is very far. We can say like this is at of 1,000 kilometers. Not thousand. You can say 500 kilometers is enough. This is just an idea that I am giving. If you are looking this charge from this distance, then it will be a point charge. Now, again, I am taking this charge and radius is 1 meter. And I am now I am at 5 meters here. This is me or someone else is looking at this charge. In this case, can you say this is a point charge?
No, sir.
No. So it's all about the distance. So, but Coulomb said that so I think now you have a clarity about the point charges. What are point charges? So we are at Coulomb's law. We are at Coulomb's law. So Coulomb's law simply tells the force or interaction between the charges. Suppose Coulomb's what Coulomb has done. Like Coulomb says that take two charges and these two charges should be point charges. This is Q1 and this is Q2. I am supposing this as Q1 and Q2. Okay. And these charges should be point charges. This is important. And suppose these charges are separated by some distance. Suppose this is R. So according to this law, and according to this law, number one, the force between these two charges, whether it is positive or negative, no matter. If positive, there will be a repulsion, both are positive. Says that force is directly proportional to the product of these two charges. He found that. And after that, he also found that this force is also inversely proportional to the distance between these two charges. And also, this force F, F is the force between two charges, depends upon the medium in which these two charges are separated. Now see here. Suppose these two hands like charges. These are two charges. So this is one charge, this is another charge. Okay. So right now there is the air in between these two charges, na? Air, na? Okay. Okay, okay. Now if somehow I remove this air from, like with the help of vacuum cleaner or and all that, you remove the air. So there will be some different medium between the charges. Now if you fill some gas, another gas like helium and all that, you can change the medium na between the charges. You can put these charges in water. We can also put these charges in water. Okay. So if you change the medium, then this force will change. And one thing more. This force F acted along the line joining the charges. Line joining the charges. So line joining, what does this statement means? Let's see. Line joining means the forces of attraction, or suppose I am supposing here the positive charges. So this force will be in this direction, like the line joining between them. The line joining between them. And this force will be equal. This force will be equal. Now let's see what does this statement mean. Suppose two charges are placed like this. Two charges are placed like this. This is Q1 and this is Q2. This is a line joining between them. Force of attraction or repulsion cannot be in this direction due to Coulomb's law. Okay, this is the meaning of this statement. The force will be in the direction like this if the charges are positive, or can be in this direction. Okay, so this statement means this: force acted along, not acted, you can write acts. Force, F means force, acts along the line joining the charge. Not like this, never. So this is, now what happened? Now we will use some mathematics. So F is directly proportional to Q1 and Q2, and F is also directly proportional to 1 by R square. Equation 1 and equation 2. What happened now? I am not specified these charges are placed in air or vacuum. These charges can be in air, can be in vacuum, can be in another medium, can be in water, can be in oil. Okay, am I audible? Are you getting my points?
Yes, sir. Yes, sir.
Okay, okay, that's fine. So I can write F is directly proportional to Q1 and Q2 divided by R square. And in 11th class, you have done these things many times, like force is directly proportional to acceleration. Like this, now you have done, no? Like in Hooke's law, you have done, if you have remembered, like
Yes.
stress is directly proportional to, when stress sigma is directly proportional to strain. When you remove this proportionality sign, then there should a constant. Okay, there should be a constant.
Okay, sir.
This thing happen in all the thing in physics. When you remove the proportionality sign, you will get some constant. You will get some constant, and that constant I am supposing k, q1 and q2 divided by r square. So, and again the value of this k. What is the value of this k? Do you know?
No, sir.
Okay. The value of this k is found to be 1 upon 4 pi epsilon naught m, where epsilon naught m is known as absolute permittivity of medium in which the charges are placed. So we have a formula when we place the charges in medium like 1 upon 4 pi epsilon naught m q1 q2 divided by r square. So this is the formula. This is the formula given by Coulomb. Fine.
Yes, sir.
Now, if I am placing these two charges, now these two charges are in some medium. Medium means medium could be anything. It could be air, it could be water, it could be oil. And now I am putting these two same charges in air. Or vacuum. So, do you know what is vacuum?
Air, sir. Closed.
What?
Like,
Like I am telling. In between my hand, what is this? What is in between my hand? Air,
air.
air, na?
Yes,
If
sir.
you remove all the air from this area, from this region, okay, then there will be nothing, and that nothing is known as vacuum.
Okay,
Vacuum
sir.
means there is no particle, nothing. Vacuum, you can say nothing is not known as vacuum. When charges are placed in air and vacuum, then the value of this force, and this is the special case, and this formula will be used very much. 1 upon 4 pi epsilon naught q1 into q2 divided by r square. And epsilon naught is what will be the here absolute permittivity of medium. What is the medium here? Medium is air, so we can say this is absolute permittivity of air or vacuum. And this 1 upon 4 pi epsilon naught have a value of 9. One thing I want to tell you before that, this epsilon naught has a value of 8.85 into 10 to the power minus 12. And when you calculate this 1 upon 4 pi epsilon naught, we know 4, we know pi, value of pi, and we also know epsilon naught. You will get 9 into 10 to the power 9. And fine na? So you should remember this formula for air when charges are placed in air. So you should use this formula 1 upon 4 pi epsilon, or you can say this k also. K Q1 Q2 divided by R square, but you should know what is the value of K in air, 1 upon 4 pi epsilon naught, and this is equal to 9 into 10 to the power 9. Okay.
Okay, sir.
Uh, have you understood something?
Yes, sir.
Okay. So here I have told you we know this already, but this scientist has calculated this thing somehow by the experiment and all that, and he gives us this formula. If the charge is in medium, then we will use this formula. If charges will be in air, then we will use this. So basically, what we are doing nothing special. We are just calculating the force between two charges, whether these charges are placed in medium or in some medium. Then the medium can be water, air, oil, or
Vacuum.
vacuum. Okay, you can say vacuum also. But vacuum is nothing. Vacuum is not. Now, have you understood?
Yes, sir.
So, in this world, there is a limitation of all the things. Like we human also have the limitation that we cannot fly like Superman. Okay. In the same way, this Coulomb's law has some limitations. You should say limitations. This formula is only valid. Only valid means we can only calculate the force with the help of this formula. Only valid for point charges. Like if I am saying this is a positive charge like this, and this charge is very big charge, means you can say that this has a radius of 2 meter. And suppose due to this charge, if I want to calculate, if there is another charge, suppose this charge is 1 meter, and these are separated by 1 meter. This is suppose positive, this is also a positive charge. So can you calculate the force with the, can you apply here? Suppose this is Q1 and this is Q2. Can you apply here? K Q1 Q2 by R square. Can you apply here or not?
No, sir.
No, because these are not point charges. So, but there will be a force between these two charges. Force will be there, but we cannot use Coulomb's law here. We will use something else for calculating that. That is different thing. But we are studying Coulomb's law. I am not going in that detail. So means only valid for point charges. When it is better to write 2 point charges, because this law tells the force in between two charges only, not the 3 and 4 charges. 4 only valid for 2 point charges. This is the limitation of this law. And second limitation is, suppose if I am saying here is a point charge, this is a point charge Q1, and this is another point charge Q2. And suppose these charges are moving with like this with some velocity v1 and v2. Like see here, this is one charge and this is another. This is one charge. This is another charge. Suppose and these are point charges, but they are moving like this. They are moving towards each other. In this case, also you cannot apply the Coulomb's law. Means in this case, this law fails. When two charges are in motion, this law is not valid. Okay, if two charges are in motion, but now this is all for limitations. But there is one thing we can do. Valid only when one of the charge in motion and another charge at rest, another charge is at rest or at rest, but the distance between them is not changing. Means distance is fixed. So let's see how this will happen. What is this? Ajmi, what is this?
Sir, a point charge.
No, no.
So, circle.
This is a circle. This is a circle. This is a circle, and suppose at the center of circle has a center, na? At the center of this circle, here a charge Q1 is placed. This charge is at the center, and another charge is placed here, Q2, and this charge is moving in this circle. So will this distance R changes when this charge move around this circle or not?
No, sir.
No, na? So it means here this law is valid. See the statement, valid only when one of the charge in motion, one of the charge in motion, this charge Q2 in motion, but Q1 at rest, and this R distance is fixed. R is fixed. So it means here we can apply this law. And this is a case with atom. This is a real case with atom. Suppose if I am supposing atom as this is a sphere, this is a atom. Okay, this is atom, and in the center of atom, what is? Do you know? What is
Point.
center of what?
Point charge.
No, no, no. Point charge. Now I am talking about atom and electron. There is a charge. You are right. Point charge like nucleus.
Nucleus. Yes.
And nucleus have a charge, na?
Yes, sir.
Here is nucleus, and this nucleus have positive charge, and around the nucleus what happened? Electron revolves, na, in the circle.
Yes, sir.
So here we can apply this law, Coulomb's law. Coulomb's law is valid in atom. Like in atom, the electrons revolves around the nucleus. So it means here we can apply this law. Here we can apply this law. So there are some limitations also, and there are some good things of this law also. At least it tells us about the force. Okay,
Okay, sir.
so do you want to note it down, or I should move forward, as this is a demo class?
I have already noted, sir. You can continue.
Okay, okay, fine. So here we can apply. So I am writing. Revolving around positively charged nucleus. Nu is for nucleus. Okay, that's fine. So now this is all about this law, and why we are studying Coulomb's law, because it tells us the force between two charges, 2 point charges. Okay, this
Okay,
is the
sir.
reason that why we are studying Coulomb's law. And what is Coulomb's law? Basically, you should remember at least this formula. This formula you should remember, and you should also remember this value for solving the question in the examination.
Okay, sir.
And you should also remember this. You can also remember this also. You are from CBSE, na? CBSE
Yes,
board.
sir. Yes, sir.
Okay, fine. So in the CBSE examination question paper, there can be the question like. So now we will move to the questions. As this is a demo class, so I cannot take much time. So like two charges, this is the question now. Of 2 coulomb and 3 coulomb are separated by 1 meter in air. Okay, in air, calculate force between them. This is just a question made by me. Okay,
Okay, sir.
this is just for calculation purpose. So what is there are two charges, and these two charges are separated by a distance of 1 meter. and here is 2 coulomb charge, and here is 3 coulomb charge, and these are positive charges. So it means that they will repel each other like this. Okay, they will repel each other like this. And what is the value of force? We know the formula for calculate, and these charges are placed in air. So we have a formula for air. This formula na
By 1/4
1
pi
upon 4 epsilon naught.
into
And you can learn this also. You can apply here as you wish. What you want to learn, 1 upon 4 pi epsilon naught q1 q2 by r square, and I have already told you the value of this. Value of this is 9 into 10 to the power 9, and the value of q1 is 2, and value of q2 is 3, and this will be r square means 1 square. So can you tell me the answer? 54 into 10 to the power 9 Newton. Fine now. 1 square means 1. 3 to the 6, 9 the 54.
Yes, sir.
So this is our answer. This type of question will be asked in the examination. Asked in the examination. Now there is one more question. Have you understood now this question?
Yes, sir.
Okay. So you should remember this formula at least. You should remember the value of K, and this is the formula. Now I am moving with the next question. Two charges. So now see, the Coulomb's law is helpful. Here we can calculate the force at least in these two charges. Two charges, and these two charges are the point charges. Okay, always consider point charges when given in the question. Two charges. If not given in the point charges, you will consider those charges as point charges. Okay. Two charges q1 and q2, when placed at a distance r in air, or you can say vacuum, repel each other with force F. Calculate, full stop here. Calculate force between them. When magnitude of both the charges are doubled and separation between them is also doubled. So before this question, I want to ask you one thing. Suppose this here is a 3q1 charge, here is 3q2 charge, and I want these charges are placed in here. I want to calculate the value of force. Please tell me what is the expression. We will use K or K na.
Yes, sir.
First we will take this charge. whole charge. This is whole charge, no?
Yes, sir.
Instead of Q1, we will take this
3Q1,
3Q1,
3Q2.
3Q2 divided by if the
Ask.
distances are. Okay. You have to take one charge at a time, 3Q1 and 3Q2. Now let's see what happened in the question. Two charges are placed. Here you can see two charges are Q1 and Q2 are placed at a distance R. Simply you should put two charges at a distance of R. No problem. And charges are given as Q1 and Q2, and these charges are placed in air. So, and here one thing is given, they repel each other with a force F. Means repel means like this, and we know how to calculate this F. This F is given in the question. We know how to calculate the value of F. We will write K Q1 Q2 by R square. This is equation 1. And now what happened? Read the question further. Calculate the force between them when magnitude of both the charges are doubled. Magnitude of both the charges are doubled means this is Q1 and this is Q2. Magnitude double means multiplied by 2. Both the charges, okay?
Okay.
And now, but the distance between these two charges is doubled, CF, and the separation between them is also doubled. Okay, separation is also doubled. Means we have increased the separation between the charges. Now the separation is okay. Separation doubled means it becomes 2R. Now we know that they are again placed in air. We know that how to calculate this force. What will be the expression of F? Will be like F is equal to K.
K to Q1.
Very good. This was the thing that I want to tell you. And that this will be 2Q2 divided by
2R square.
Very good. 2R whole square. Fine now? And now you can see that what we have done, we have separated the distance. We have separated the distance and we have separated the charge also. So force will change now.
Yes, sir.
Here we have changed this Q1 and Q2, and we have changed the distance between them, means force will change. So I am supposing this force as F1. That we have to, this force F1 we will have to calculate. See here, calculate force between them when. Okay, calculate force between them. We have to calculate the force between them when magnitude of charges are, means force is changed. So I am not writing F, I am writing F1. So now from here I can write this K will remain same. And one thing more, if air is not changing, is medium is not changing, means this K is not changing. What is K? K is 1/4 pi epsilon naught. Okay, this is not changing, this is constant. I am not writing in this form because this will become too long. So I prefer to write in the form of K. You can also write in any form as you want, but you should know at least. So what happened? Now what will here what will come here? 2 2s are 4, k into 2 2s are 4 into q1 q2. And what is this? This will be 4r square. Look,
Yes.
2r square means 2 2s are 4 and r square. This will be 4r square. Fine.
Okay, sir.
So F1 becomes 4k q1 q2 y r square. Now let's see. Now let's see this. This is equal to F now.
Yes, sir.
This thing is equal to this F. So I can write F instead of this. Oh, sorry. Here 4 will also come. This is 4 now. This is 2 2s of
Yes,
4 r
sir.
square. It will be 4r square. And this 4 and 4 will be cancelled out. This 4 and 4 will be cancelled out. So means F1 will become k q1 q2 by 1 minute. Okay, now k 4k. This will be 4k and q1 q2 and this will be 4r square. Now it's okay. And now we will cancel out 4 and 4. 4 and 4 will be get cancelled out. Then F1 will become
K Q1 Q2 by R square.
k q1 q2 by r square. And now what is this? This is F na?
Yes,
This
sir.
is F. K q1 q2 by r square equal to F. So I can write here F equal to F. So means the force F1 is equal to F. Means the force will not change. Why the here the force is not changing? Because along with the charges, the distance is also increasing. As we increase, okay, that's why here the force is compensated. Means when you increase the charges, the force will increase. But when you increase the distance, the force will decrease. Increase plus decrease means no change.
Okay, sir.
So the value, the answer is this.
Okay.
So this is all about today's class, and now let's recap. This is something else, and now from this chapter we have started electric charges and fields. Now I have told you what is charge. Charge is something. So charge is a property. Charge is a property, and charge are of two type, like positive charge, negative charge. Okay, and charge is also a scalar quantity, as we can add these charges. Now I have told you this thing you have already known, and we have simply calculate this force with the help of Coulomb's law. We have discussed Coulomb's law, and this we have discussed what are the point charges. What are the point charges? So point charges have not any fixed definition, but the point charges does depend on the distance from where we are watching or seeing. And after that, I have discussed about the Coulomb's law. What is Coulomb's law? This is depend upon the product of the two charges and inversely proportional to the distance. And this force also depend on the medium. When you will place the system in another medium, means in water, so the force will change, and this force along acts along the line joining the two charges. Okay, I have given the example also. And after that we come to this formula, and when the charges are placed in air, then we replace em with epsilon m with epsilon naught. I have told you the value of epsilon naught m, and I have told you the value of this f k by k q1 q2 by r square, and k equal to 9 to 10 power 9. And there are some limitation of this law, valid only for point charges, and 2 point charges should not be in motion. And this is valid only when one charge is in motion and another charge is at rest, but the distance between them is not changing, like in case of atom and nucleus. Okay, and after that we have this numerical. We have simply applied